Hello everyone, and welcome to the Dynamic Array Exercise lecture. In this lecture, we're going to be implementing our own Dynamic Array class. So, as always, there's a notebook associated with this since it's a live coding lecture. If you go to the Array Sequences folder, under Dynamic Array Exercise.ipython notebook here, if you click on that, you'll get this Dynamic Array Exercise notebook, and it has all the code as well as some notes and lots of comments for you to fully understand what we're going to go through this lecture. So we're going to basically be implementing this class Dynamic Array. It's going to act similarly to a Python list. So let's go ahead and get started. Really quickly before we begin, we're going to be taking advantage of two features of Python. One is a built-in library called ctypes. You can check out the documentation link here for more information, but it's basically just going to be used here as a raw array holder. If you scroll down to the very bottom of the dynamic array class that we're going to be building, that's the only part where we use it, where we actually make a new array. Okay, and then the second note that I want you to be aware of is we used an underscore before method's name to keep it non-public. So we'll show a quick example of that by copying and pasting this code into the notebook. So for instance now, if I say lowercase m is equal to an instance of that m class, if I do m.tab, I will get public out. But notice I won't get a list containing private because it has that underscore. I would have to specify underscore in order to see all the special methods available to me, and at the very end, one of them will be private. So we're going to make use of that just because certain methods don't make sense for the user to be able to call them. All right, with that all being said, let's go ahead and get started on implementing our own array class. So we've cleared all the cells, and we're going to go ahead and start our implementation. First thing I'm going to do is just import that ctypes, and we'll get into that later on why we actually need to do that. So let's start building out our class. We'll call our class Dynamic Array. And remember, it's pep8 to have this capitalized. Pass an object. And let's go ahead and get started. First, we want to initialize. So underscore underscore init underscore underscore, and we're just going to pass in self. And there's essentially three attributes that we're going to have here. We're going to have n. We're going to start it at 0. So this is going to be the actual count of the actual elements. So by default, it's 0. We're going to have capacity be another attribute. By default, it'll just be 1, so it can accept only one element by default. Remember, we're going to be using a dynamic array style in order to implement larger capacities, and we'll show methods to do that later on. And then finally, I'm going to say self.a, and that's going to be equal to self dot another method, which we'll call make array, and we'll build that out later. And it's going to pass in capacity. Okay, so we have these three attributes: the count actual elements with n, the capacity default is 1, and the self.a, which we'll call make array, which we're going to build out later on. The next one we want to do is a special method, length. It's going to pass in just self, and this is going to return number of elements stored in the array. So all it's going to do is return self.n. All right. And then one more special method we want to do is get item. This is going to take in self, of course, and it's also going to take in a k parameter. And what this is going to do is it's going to return the elements at index k. So after creating a dynamic array, you can use indexing to return the element at index. So I'm going to say if not 0 less than or equal to k, less than or equal to self.n. Remember, that's the count of the actual elements. Basically, this is saying if that k, that index you pass, isn't actually in between 0 and the count of the actual elements, we'll have to return some sort of error. In this case, there's a specific error for this index error. So make sure you go ahead and review errors and exceptions if you don't understand what this sort of syntax is. But what this is just going to do, it's going to print out k is out of bounds if you happen to ask for a k that's out of bounds of the array. So if that clears, then we're just going to say return self.a of k. So we're going to retrieve from our labeled a array at index k. And the reason we're using that self.a notation is to reflect back on the diagrams from the previous lecture where we had two arrays, A and B array. So we'll also keep the B array notation later on as we implement this further. All right. Next method we're going to create is the append method. So this is going to add an element to the end of the array. So I'm going to say append. We can zoom in here a little bit. I'm going to say append. It's going to take self argument since we're acting on that instance of the object. And it's also going to take ele, which stands for element. So it's going to add that element, that ele, to the end of the array. And this is where we're going to have to check our capacity. So as we mentioned in the previous lecture, I'm going to say if self.n, so the count of the actual elements, if that's equal to the capacity, self.capacity, colon, then I'm going to say self dot, and what I'm going to have to do is if my current count is equal to my capacity, I'm going to double the capacity if there isn't enough room. So later on, what I'm going to do is create a private method called resize. So in this case, I'll say underscore resize 2 times self capacity, and just keep a note here, 2x if capacity isn't enough. All right. So when we're going to append an element, we check to see if our current count is equal to our capacity. If it is, we're going to resize and double it. After we do that, we can say self of our A array, pass in n, and set it equal to ele. So we set self.n index to the elements, and then since that's equal to the element, what I'm going to have to do is add 1 to that count. All right, so we double the capacity, and then we take that last one at n, that last count, set it equal to that new element that we're appending here, and then add 1 to n to our count. All right, so since we mentioned this underscore resize special method here, let's go ahead and build that out. So I'm going to say def underscore resize. It's going to take in self, and then it's also going to take an argument, new cap, which is the new capacity, which is what we were passing in here that I'm highlighting right now, 2 times the current capacity, self.capacity. And this is going to resize the internal array to the capacity of that new underscore cap. So we're going to use the same sort of notation we used in the last lecture, b. So I'm going to say this b array is equal to self dot make array, and we're going to be using that ctypes library that I mentioned earlier to use that make array method. We haven't developed it yet, but we'll do it after we finish out this resize method. So we're going to make array, and it's going to accept new cap as an argument. So we make a new bigger array and call it b. And then we say for k in range self.n. So we reference all the existing values. I'm going to set b of k equal to self.ak. So here I'm just referencing, as we saw in that previous diagram in the previous lecture, basically referencing all the existing values from A into B. Once we're done with that, I'm going to say self.a is now equal to B. So I call A now that new bigger array. And then I say self.capacity is equal to new cap. So I reset that capacity. All right. And then lastly, we're just going to make a method that actually makes arrays. And this is going to make the raw array that we're actually creating. And this is going to take in self and new cap. And this returns a new array with the new cap capacity. And so we're going to be using that ctypes library here. It's just going to be a one-liner. Don't worry too much about what we're actually typing and how this is working. You can essentially just think about it as grabbing those raw bytes and creating that array. And so it's going to be new cap times ctypes.py underscore object and close parentheses afterwards. So just go ahead and feel free to copy this line from the Jupyter notebook that's available to you. So that's it. That's our entire dynamic array class. Let's go ahead and run it, this cell, and make sure we haven't messed anything up. All right. Let's make a variable called ARR and instantiate it as a dynamic array. Run it. All right, looks like it's working so far. So let's go ahead and do some things to it. Let's go ahead and say r.append. Let's append the integer 1 to it. All right, now let's check the length of our array, and it's 1. So let's go ahead and append another array. Or excuse me, another integer. And now let's check the length of the array. And it looks like the length is now 2. And now let's see if we can actually access it using indexing methods. And it looks like we can. So at index 0 we have 1, and at index 1 we have 2. All right, so that was it. We actually made our own dynamic array. Let's go ahead and do a quick rundown of all the methods since we created them all. So we're going to zoom out a bit here. So starting off with the class dynamic array object, we started with some attributes here, self.n, which was the actual count of the elements in the array. We start off with 0 elements in the array. Then we have the capacity of the array. We start off with just being able to hold 1 element. And then we have self.a equal to self.makeArray of self.capacity. So in this case, when we start out, we set a equal to an array of capacity 1. So we come down here and using that ctypes library actually make that raw array. Then we start off with some special methods, length, just to return that count, get item, that allows us to index, but first we do a check to see if it's actually inbounds for that k. If it is, we just return a indexed k. And then we have this append. And this is really the key to understanding all of this, is that we check our actual count against the capacity. And if it's equal to it, then we resize to double the capacity. And that's really the main point of this dynamic array, that instead of having this huge array since the beginning, we just check as we add elements if our count is equal to the capacity, and we double if the capacity isn't enough. That's really what makes this array a dynamic array. And we can keep adding to it, and the space that we have will keep growing as we go along. Then once we do that, we just say a at self.n is equal to element, and we add a count at that n. Then we created a method called resize, which sets this array b, almost like a temporary array, equal to make array at that new capacity. Then it says for k in range, self.n, we basically re-reference everything in a to b, and then we set self.a equal to b again, and we set the capacity equal to the new cap. And then finally, this make array uses the ctypes library to make that raw array that we're referencing throughout the entire class of this dynamic array object. Okay, so that's it. What I want you to do now as a little homework assignment is play around with it, and I want you to see how it auto-resizes. So try using the same sys.getSizeOf. So if I jump over to the Jupyter Notebook, try using this right here. Let me zoom in on it for you guys. This sys.getSizeOf. As remember, if in some previous lectures, we used that to see how many bytes were actually being held. So go ahead and check the length of the array, and then check the size of it, and see how it changes and doubles as you add more elements and reach certain capacities. All right, that's it for this lecture. I hope it was interesting for you to see our own implementation of a dynamic array. And remember, the key takeaway is really this append method here, where we're checking the capacity and doubling it if there isn't enough room, and how we're resizing the array by referencing a new array to all the existing values, and then resetting A to that new array B. Okay, thanks everyone so much, and I will see you at the next lecture.